so 125m cubed plus 1. We always look for a GCF. 1 is one of our terms, so obviously there is not a GCF. So we look at our list and we check and see if 125 and 1 are perfect cubes, and they are. 125 is 5 cubed, 1 is 1 cubed. A lot of people tend to overlook 1, but 1 is a perfect everything. Perfect square, perfect cube, perfect fourth. Okay, it doesn't matter. All right, so 2 sets of parentheses. Binomial, trinomial. So the second set should be a little bit bigger. The cubed root of 125 is 5 because 5 cubed is 125. The cubed root of m cubed is m. The cube root of 1 is 1. So that's our first set of parentheses. We build the second set from the first set. So for the first term, we square the 5m. I'm just going to write out what we're doing first, and then I'll simplify it. As you're doing these, you'll get to the point where you don't need to write out this step, but I want you to see where this comes from. So we square the first term. We multiply those 2 terms from the first set of parentheses together, so 5m times 1, and then we square the second term, and that goes last. Then we use SOAP. The same sign. We started with a plus, so a plus goes in the first space there. Opposite, okay, so that's a minus, and then the last term is always positive. Okay, let's simplify this. 5m plus 1, 25m squared minus 5m plus 1. Okay, so that's the simplified. Okay, so pretty simple. Steps are always the same. This is actually easier than factoring quadratics because the process is always the same thing. You don't, there's no guessing and checking. There's nothing you have to figure out. It is all right there. Okay. All right, so let's look at example B. Eli, you can sit somewhere else. Okay. Example B, we've got 8 plus 27m cubed. Okay, I know y'all don't like when that variable comes second, but let's just leave it in order. Okay, let's just leave it in the order that it's in so that we don't mess up the factoring. All right, so 8 and 27 don't have anything in common. 8 and 27 are both perfect cubes. So the cube root of 8 is 2. The cube root of 27 is 3. And the cube root of m is m. So it's 2 and 3m in our first set of parentheses. Okay, again, I'm going to show you how I build it. So 2 squared, 2 times 3m, and 3m squared. SOAP, same sign. We had a plus between those 2 terms, so it's a plus. Opposite is a minus, and the last term is always positive. So to finalize this, we've got 2 plus 3m. 2 squared is 4. 2 times 3m is 6m. And 3m squared is 9m squared. Now, I didn't mention this in the first problem, but this trinomial right here never factors further. Okay, this never factors further. Remember, I know that it looks like we just took a very simple problem and made it a more complex problem because we went from 2 terms to 5 terms. So what was the whole point in doing that? Well, what's the point of factoring? It's to be able to solve equations. So this is a cubic equation, 3rd degree. We're expecting 3 solutions. But I promise you, if you look at the graph of this, you're probably only going to see 1 solution. The other 2 are either imaginary or they're not whole numbers. So what we've done is we've broken this into a linear factor, which is very easy to solve for. We could solve that. That's what, -2/3 for the first one. Okay, and then we've split it into a quadratic, which doesn't factor any further, but if it can't be factored, then we can always use the quadratic formula, okay? We'll get into that next week. But that's the whole purpose in doing this. Yes, it looks like we just made it a lot bigger, but we put it in a form where we can find all three solutions without relying upon our calculator. Okay, let's look at C. A lot of people tend to overlook this one, and this is why I put it on there. M cubed plus 1. I mentioned at the very beginning, 1 is a perfect everything. So there's obviously no GCF. The cube root of m cubed is m. The cube root of 1 is 1. We square the m. We multiply the 1 and the m together, and we square 1. You don't have to put the 1 in front of the m there in the middle. I'm just showing you where it came from. Okay, so same, opposite, always positive. I'm not going to rewrite this one because it's right there. Okay. Now, example D, 256 and 108 are not perfect cubes on our list. So that must mean, it looks like it should be the sum of perfect cubes, but it's not. So that must mean that there's a GCF. I'm thinking that these are divisible by 3. So let's start by taking out a 3. 256 divided by 3 is... Whoa, I had the cube root in there. My bad. Nope, it's not 3. Okay. I think it's 4. 108 is divisible by 3, but 256 is not. 256 divided by 4. There we go. That's better. 64x cubed plus, what would that be? 27. 108 divided by 4 is 27. Okay. So now let's factor our sum of perfect cubes because 64 and 27 are perfect cubes. So don't forget, you got to bring down that GCF. It doesn't just disappear once we factor it out. It's still there. So the cube root of 64 is 4. The cube root of x is x. Or excuse me, the cube root of x cubed is x. Cube root of 27 is 3. Okay, we square the 4x. We multiply the 4x and the 3 together. And we square the 3. So same, opposite, always positive. And let's finalize it. 4 times 4x plus 3 times 16x squared minus 12x plus 9. Okay, one more just to make sure we've got it. Factor out the 4. Got x cubed plus 1. We just factored that a second ago. It was just a different variable. So that's, whoops, got to mess up my signs here. Getting a little carried away. So same is a plus, opposite's a minus, always positive, plus. And that is the final answer.